All right. Thank you very much for inviting me. Hitch and I have go back about 10 years or so, and as you probably all know, you can't get rid of Hitch. He's just going to always be after you if he thinks you can provide some value to this organization or to the resource. Very highly committed individual, and I commend him for continuing to do that. He invited me here not because you folks duck hunt on springs, but because you wanted to deal with all water resource issues and get a feel for what's going on, I guess, statewide. And a lot of the issues are very similar, of course, across all systems. So I've had the pleasure of being the director of the Springs Protection Initiative at St. John's for the past 3 years. It's been a very active area, and it's been a real pleasure to be involved in that. There's been a lot of political focus as well as scientific focus on our end on that, and a lot of project work. And I'm going to talk about a little bit of all that today. I'm going to do a very brief overview of springs in Florida and really about the challenges that we face. Talk about the legislative action from this year, which for springs was actually very positive. Then I'll talk about the St. Johns River experience, this initiative that we launched a few years ago, and talk about a research effort we have at the University of Florida. Talk about our restoration projects at a very high level and focus in on one area. We're doing a lot of good work that is sort of an emerging success story. Then I'm going to do a bit of a whirlwind tour of what's happening in the rest of the districts. And the reason the districts are so vital to this, there's been money applied over the past 3 years from the legislature to help on springs restoration. What the state has done is DEP has looked to the districts to bring projects to them. And so what we're doing collectively with DEP, and most importantly, the local partners, be they utilities or local governments, that's where the action is happening. And I'll show you some examples of a few particular projects, as well as, again, at some regional emphases that's going on that will demonstrate that there is a lot of good stuff going on. It's a big hill to climb, granted, but we are making some progress. And then a few conclusions and questions if we have some time. So, springs in Florida, 700 are officially named. You'll see bandied about over 1,000, which is probably true. As most of you know, being outdoors people, these are a phenomenal resource, and this is the highest concentration anywhere on the planet for springs. And it is a phenomenal resource, and again, I've been happy to be heavily involved. We have had some pretty profound changes in Florida springs. This is an example. This is Weeki Wachee back in the good old days when you had your eelgrass community, and these aren't the mermaids, but you know, not bad. But here's Weeki Wachee in 2006, and that's an algae that has taken over completely. You've had a complete shift of that ecosystem. That's not a good thing. So the problems that we've identified to date, as indicated, the ecological structure of these systems have changed profoundly. You have high nitrates, you have less natives, you got a lot of attached algae, you also have filamentous algae, you've got much lower fish abundance in some cases, and basically just an impaired ecosystem metabolism. And this isn't just springs, because they're beautiful and they're a natural resource, but they are the indicator of our Florida aquifer, where we get 95% of our drinking water. So paying attention to springs is, again, the kind of canary in the coal mine, is something worth doing. So our primary challenges are to protect and improve water quality, and to protect and recover flows in spring systems. And we're also looking at some other nuances, which I'll get into relative to our UF research. This is just one example of a case study, Wekiva Spring, which is down near Orlando. Just to give you an idea of the distribution of the loadings to the system of nitrate. If you start at the top here, work your way around, you'll notice that almost half of it is various forms of fertilizer that are causing problems in the springs. You get over to this side, you've got wastewater, either in the form of wastewater treatment plants or septic tanks. We have to, based on the total maximum daily load established for this system, we have to have an 80% reduction in nitrate to get to the target level. So clearly, no one silver bullet. Even if you took every septic tank off or you kicked all agriculture out of the system, you're still not going to get there. Every sector is going to have to do their part to achieve a target goal of 0.35 milligrams per liter of nitrate. So that's it for the overview. As far as the legislative action, they did do a lot relative to springs. And this is a fairly dense slide, but I'll just mention quickly the minimum flows and levels. This has been an ongoing issue where the water management districts are obligated to establish a minimum acceptable flow or minimum level on a water body that will not result in significant harm. We need to establish a baseline. Those have been going on for years. However, they were lagging behind a bit here and there, so they set a deadline of July 1, 2017 for all the outstanding Florida springs, which is about 37 that they named, which is all the first magnitudes plus a few others. In Northwest Florida, since they really had almost no data collection in Northwest Florida, they were given until 2026 to come up with their MFLs. As far as BMAPs or Basin Management Action Plans, deadlines were also established for those. That process had been going on, but again, they wanted to say, get this stuff done. And that's done. Generally speaking, the deadlines for those are going to be July 1st of 2018. In each of those, the septic tank remediation plan is required. So in any outstanding Florida spring where at least 20% of the loading is attributed to septic tanks, DEP has to come up with a plan in conjunction with their stakeholders, which is all the local governments and utilities, to come up with a plan to remediate or eliminate that load and achieve the target reduction from that sector. Oops. Also, local fertilizer ordinance adoption is required. And then there are some prohibitions. Any wastewater treatment plant greater than 100,000 gallons per day is not allowed unless it's at AWT, which is 0.3 milligrams per liter. No septic tanks unless it's greater than 1 acre. New ag operations have to have BMPs, and no new hazardous waste facilities. So Senate Bill 552, which passed this year, really was a pretty good bill for springs. And the other reason it was such a good session was the Florida Legacy Act, or Legacy Florida Act was passed, and they earmarked $50 million per year for the next 20 years of Amendment 1 dollars towards springs restoration. That's $1 billion. That's huge. That's a major commitment. That Amendment 1 that was passed a few years ago, they're finally starting to funnel that money out in ways that are going to help benefit the resource. So that's a huge step forward. And what happens here, this $1 billion will be leveraged with water management district dollars as well as all these utility dollars. So you're going to be looking at more than $2 billion worth of work being done thanks to that $1 billion. So again, a good year for springs, legislatively speaking. I mentioned back in the day, 2013-14, we kicked off a Springs Protection Initiative at St. John's. And frankly, the reason we did it, everywhere else in our district, we had trends going the right way. I will say we've had a huge setback in the Indian River Lagoon. However, at that time, in 2010, 2011, everything was looking good. We were getting almost historic levels of seagrass in the lagoon. We had progress in numerous lake systems. We decided springs was the last great challenge, and it's understandable why. It's where everything on the surface accumulates and gets distributed, so you have to deal with everything up there. It's not as easy as looking at a surface water where you can kind of, model pretty easily where that water's coming from. When you look at springs, it's much more challenging. You don't know where all those conduits are underground. You don't know exactly what the different migration rates of nutrients are, how much is taken up in the soils, et cetera, et cetera. So we left it to last, but we at least got started. But to address these complicated issues, we did get with UF through an RFP type process. And so I will talk about that momentarily as one of the keys of our Springs Protection Initiative. And what that will do is it will inform our future water supply planning and our future regulatory programs, be they consumptive use permitting, environmental resource permitting, or minimum flows and levels. We've also launched a lot of projects. We weren't going to sit around and wait till all the science was done. Conventional wisdom said do X, Y, and Z, and we have started on that. But this initiative has been very aggressive and, from my opinion, pretty successful so far. So that's kind of the overview of the initiative. As far as the research program goes, we didn't come up with this acronym. UF did, the Collaborative Research Initiative on Sustainability and Protection of Springs, or CRISPS. So I can't even remember what it says, so I just refer to the UF research program most of the time. But it is a pretty comprehensive look, and it is very collaborative. We did an RFP. UF sent in a very strong proposal, and what we've done is we have created a very integrated relationship with UF. They've probably got 8 to 10 principal investigators, people like Wendy Graham, Tom Frazier, Matt Cohen, a lot of other very well-known researchers at UF, as well as we have a counterpart at St. John's, and each of us have working groups. They've got a bunch of postdocs and grad students, and we've got a bunch of engineers, hydrologists, and environmental scientists. So we've got organized teams to do an interdisciplinary study. We're looking at multiple spring systems. Our main focus is right here at Silver Springs. It's very close, it's iconic, it's got lots of issues, but we're doing as many as 14 springs in a synoptic survey, et cetera, to get some background. We're also looking at springs in the Ocala National Forest for baseline. You look at what's going on in Juniper Springs, well, our nitrate loads are real low because there's no anthropogenic effects. So we're going to get it kind of the bookends of the situation out there between healthy springs and not healthy springs, and then we are going to come up with eventually the strategic management options that should be pursued. This again is very dense. I'm just going to read it quickly, but I want to give you a flavor of why we're doing this. We need to find out where it's most feasible and cost effective to deal with nitrate loadings. We know nitrate loadings are a problem. Question 2, will the nitrate loading reduction alone be sufficient to solve the problems? We don't think so. We look at Alexander Spring, which has remarkably low nitrate. It's got the same kind of algae problems. What's going on? So we need to figure that out. And then what are the relative influences and manageabilities of nitrate and non-nitrate causes for this excess algae, which is kind of the key indicator of a problem in the springs. Just for example, there are issues where if you've exterminated, say, a snail population by virtue of perhaps treating aquatic vegetation, you don't have those snails now to eat that algae that grows on the eelgrass. That eelgrass gets shaded and shaded and shaded, and it could be gone. I mean, look at your fish tank. You know, if you don't have a snail in there, what's happening? You're getting the algae. We have issues where, again, there are cases of that sort. There could be direct toxicity due to high nitrate to some of our native plants. There are a lot of different factors that we do need to look at. Silver Springs, for example, there's been a loss of connectivity with the St. Johns River. A lot of migratory species used to come up there and feed on some of the algae. They're no longer there. Manatees are no longer there. So there are a lot of issues that we're trying to ferret out with UF's help. What I'm going to focus on mainly today, though, is what we're doing, the turn dirt component of this project, because I want you all to understand that there is a lot going on. In St. John's, we've got about 150 springs identified. The key ones, you'll notice a couple. Alexander and Silver Glen are in the Ocala National Forest. They're in good shape nitrate-wise, but like I said, we still have some issues with intense algae issues in Alexander. Volusia Blue and Silver both need serious attention, and I'm going to focus on Volusia Blue as part of a potentially emerging success story. In general, I will be focusing, or most of our work's being done at Silver, in the Wekiva system, and Volusia Blue. This is where a lot of the project work has been going on. There are also a series of springs up here just outside of our district in the lower Santa Fe, where we do projects in our district or fund projects in our district that actually influence loadings there. Again, surface hydrologic boundaries aren't the same as subsurface hydrologic boundaries. So we have funded some projects in this region that actually help springs in the Santa Fe system. So how does this typically work? We're doing a lot of science, and we're also providing funding, and we're also brainstorming with local governments and utilities what kind of projects should be done. DEP does pull people together for these BMAP processes to help identify projects, and they also are the conduit for the funding from the legislature. But really and truly, where the rubber meets the road is the utilities and local governments that are out there that are turning the dirt and implementing the projects. And I'll talk about a lot of those. As I mentioned, most of our work's being done with Wekiva, Volusia Blue, Silver, Lower Santa Fe. The types of projects are water conservation, reclaimed water systems, which take pressure off groundwater withdrawals. Similar, alternative water supply development takes pressure off groundwater. And then various water quality types, where we're helping fund wastewater plant upgrades, septic tank conversions, and stormwater treatment. Some of the innovative technologies, we're looking at potable reuse, which is drinking it instead of just, not using it as efficiently as possible. And then one of our more interesting experiments here is to use a media in a rapid infiltration basin where they're dumping all the wastewater to strip the nitrate before it gets to the aquifer. And we think this could be a very cost-effective mechanism to accomplish that. So what has the district done financially and collectively with our partners? Since fiscal year 2014, basically, in the last 3 years, $101 million between these three partners. And as you'll see, again, it's mostly the local governments with the heavy lifting. We've done our fair share, and DEP Springs money has done the rest. So that's a pretty good start. Again, if we got to spend about $2 billion and we spent 101, just ballparking it. To date, we've had 57 projects, 27 partners, almost 1 million pounds per year of nitrogen reduction, and 71 million gallons of water per day saved. So I want to talk about Volusia Blue, an emerging success story, if you will. A little hard to see here, but Blue Spring is right there. And in this region, we did an MFL for Blue Spring and actually all these other little lakes in the system, Hires, Doherty, et cetera, and Indian. And what we determined when we did the MFL was that by 2030, these systems are not going to be viable. They're going to be below the minimum required levels in the lakes or flow in the spring. So you do a prevention strategy. And Blue Spring is the one I'm going to focus on here, although all these will be addressed. So the driving force, believe it or not, at Volusia Blue, we were pushed by DEP at the time as well as Fish and Wildlife Service. There was a remarkably fast-growing manatee population. Volusia Blue is the winter refuge for this population. And so we had to increase flow to keep up with that increasing population. The projected population increase was like this. The real population increase has been like that. So even though when we first set this, people thought we were over-exaggerating the increase, that's not true. Now, of course, this will flatten out. They're going to come into some resource constraints, food primarily in the area. But it's still valid that we need to increase flow there. Oops. Okay, so these are the projects. Again, can't see them too well, but everything in blue, those are reclaim or reuse projects, which again, take pressure off groundwater. The green ones are aquifer recharge. We're actually getting water in, and here's where that substance where you've got a wastewater plant putting water into the ground, strip the nitrate out, because you don't want to increase the water quality problem there, but you want to get the water into the system. And then moving some of the water supply fields away from these lakes that are problematic and spreading them out. Those are the water supply projects. So we've already implemented, or all these are underway or implemented so far, various projects around the region to, again, help Blue Spring. And rolled up, we're going to achieve 16 CFS increase, cubic feet per section increase by 2030 Total capital cost about $155 million. And by implementing these, we will achieve aquifer levels sufficient to meet Volusia Blue Spring and Lake MFLs, also accommodate future water demands and the healthy manatee population. So we started funding this probably 3 to 4 years ago. We're pretty well underway. And again, this is what I would call an emerging success story. So moving on to the rest of the districts, and I don't know exactly how much time, so how fast I need to go through this. Oh, we're doing well. What I'll do on these is either either feature an individual project or again a regional area that they've been working on that they're showing some progress on. In the Suwannee District, the so-called Springs Heartland, they do have a lot of first magnitude springs up in this region, all along the Suwannee system and lower Santa Fe system. There you go. They have the highest concentration in Florida, which is also probably in the world. 21 of 33 first magnitude springs, water in state parks, 7 billion gallons of water a day, 72% of the annual flow of the Suwannee River system come from springs. So the springs along here, along the Suwannee, Santa Fe, Chetucknee, Steinhatchee, Wassissa, Waukesasa, et cetera, the project types are very much agriculture centered because 95% of the issues up there are agriculture related. There are more cows than people up there and lots of crops. So water use efficiency, primarily in the agriculture arena, water quality, a little bit in septic tanks, and they did do a major upgrade at Lake City on their wastewater plant, and then a lot of agricultural activity to deal both with water quality and water supply. Retrofits and fertigation type activities, and really just trying to get to systems that are much less wasteful on water instead of having the giant spray that just kind of dissipates, evaporates. You drop it with these and it gets on the crop much faster, and of course you want to water not in the middle of the day, but early morning preferably. So what have they done, financially speaking? A lot of this has been provided by DEP because the tax base at Suwannee River is not as high. But you have seen locals put in $20 million, Suwannee River put in about 8-ish, I guess, and the state put in about 26. So 50 plus million in the Suwannee system. The one project I wanted to talk about is Mallory Swamp, where what's in the greenish area is publicly owned, the rest is privately owned, but this whole swamp region has been drained by these canals. So what they're going to do simply is, put ditch blocks essentially in all these canals and maybe some other slightly more sophisticated structures, but just keep the water in the system instead of draining it off directly to the river systems. But what's really interesting here is what that allows is kind of a gentle flow over to all these light blue areas that are sandhill lakes. And frankly, that's where the recharge takes place, is in these little sandhill lakes. And so you're going to get up to 10 million gallons a day of recharge and 4,000 acres of wetland restoration in Mallory Swamp. And that's probably one of their best, most cost-effective projects. So moving on to Northwest Florida, out in the Panhandle, they've got a lot of springs also, 5 first magnitudes. We'll talk about Wakulla in particular. What they've done to date, also a little over $50 million worth of work with various other partners. And again, here also, DEP has had to be the major player. Notice Northwest Florida has a remarkably low millage rate. They cannot generate much funding, so everything they do has to be pretty much from others. But they help coordinate the activity, so there is some value there. So what they've done specifically, they've only done 5 projects, if you will. However, if you look at what's been done regionally, the biggest one was the Tallahassee sewer system upgrade, which was a $227 million project. And the reason that was done to protect Wakulla Spring was there's pretty much a conduit from where that spray field was to Wakulla Spring. And so what we really do have here is we've had a lot of projects done, smaller projects also, and a few more on the books. But that one was the major contributor to actually getting a reduction in our nitrate loads. We're almost down to the 0.35 milligrams per liter TMDL for nitrate for Wakulla Spring. So it cost $319 million to get us here, but that's money well spent. You will see they did run the glass bottom boats for the first time in a number of years, I think over the Memorial Day weekend. You didn't have the 100+ feet visibility, but you did have 60 or 70, which is much better than it has been. Now there's one other factor here that actually may be in play, which some have theorized that there's been a change in conduit flow. Spring Creek, which is a little further east of there, does not flow nearly as much. They think there's been a shift in flow, and that tannic water is actually getting into Wakulla, and that's what's contributing to the dark water. That has not been proven, but that is one operating theory. But the bottom line here, at least, we're getting the nitrate to a level that is pretty acceptable. So that, to me, is a pretty good success story. Go to Swiftmud. They also have a number of springs. They focus primarily in the Kings Bay region. You've got Rainbow, Kings Bay, Homosassa, Chassahowitzka, and Weeki Wachee are the 5 big first mags. And they have focused heavily in that area. They've set up an NEP type program. It's patterned after the National Estuary Program type setup, where you have a steering committee and management committee, technical working group. They're getting all the stakeholders together, and they're going to come up with comprehensive plans to address the problems in all 5 of these first magnitude springs. They've started off pretty heavily. They've got a lot of small projects going. They're very actively engaged. Their conceptual budget for getting everything done is about $100 million for the Crystal River Kings Bay site. And to date, they have invested a total of about $37.4 million in these active springs projects. One reason their numbers are a little lower, their board has made a decision not to fund conversions of wastewater plants or conversions of septic tanks, or upgrades of wastewater plants or conversions of septic tanks. So those are kind of pricey, but they have chosen not to do that yet, but they may choose to do so in the future. One project I'll focus on, just because it's somewhat interesting, can't see it too well, but this is Hunter Spring. If you've been over there, Kings Bay is more down in here and over here. Hunter Spring is a little offshoot of that. What was happening here is you basically had the filamentous algae covering the bottom, basically muck and filamentous algae. So what they've gone in here is with an active restoration program where they're taking these, folks are growing eelgrass on coconut mats, and they've gone in and they've dredged out these pockets, and then they lay these mats of eelgrass, and they have to fence them off because otherwise the manatees will come in and just chop them right down to nothing. But again, not a great visual right here, but this is the filamentous algae that was on the bottom, and they're converting these areas to good vallisneria beds. And so that's the plan there. That's they've done a few very aggressive on-the-ground type restoration projects. That first photo I showed you at Weeki Wachee, they went in and dredged all that out. They did the same thing, tried to get some planting. They didn't protect the plants. The manatees did eat them all. They came back and replanted with fencing, and they're getting some progress there. So that's it for the whirlwind tour of the districts. In conclusion, I would say that this is an immense challenge. This is not going to be solved overnight. Again, 80% reduction in nitrate, for example, and that's not atypical. I mean, 50, 60, 80% reduction in springs is not atypical. There are substantial ongoing efforts, as I've indicated, that have been helpful, and they're going to help reverse water quality and spring flow trends. Legislative funding and Amendment 1 funding, or legislation and Amendment 1 funding were very valuable and are going to help expedite things. And we at UF, with UF, are coming up with a deeper scientific understanding to make sure that what monies are spent are going to be spent, on the most cost-effective solutions out there. So I'm looking forward to maybe at some point, 2 years from now, come back and tell you the results of that science. And we will be sharing that information, of course, with all the other water management districts, DEP, all other interested parties. We have a very open process with the nonprofits as well. The Springs Institute attends our meetings and whatnot. So we are looking to try to come up with the, again, best approaches to dealing with the restoration challenge of our springs.
We have about 5 minutes if you'd like to ask some questions.
Yes, sir.
From South Florida and everything in South Florida is phosphorus. Why is it just nitrate and not phosphorus?
The limiting factor in springs is not phosphorus, it's nitrogen. I can't give you the scientific explanation for that, but typically, and Dr. Burrill probably could, but in most of your coastal systems, it's going to be nitrogen. In your spring systems, it's going to be nitrogen. In your lake systems and marsh systems, it's typically going to be phosphorus. And Dr. Burrill will be talking a little bit, so you can ask him that. He can probably explain it to you. Yes, sir.
The test that you're doing in the ribs to reduce nitrates, could you maybe explain that a little bit more, what that is?
Yes. The substance we're using, and actually, again, we're having a partner do it. We're helping fund it. City of DeLand has stepped up to do it. And what they've got is a current rapid infiltration basin. They're dividing it in half. Keep one as a control. The other one, they're excavating and putting in BAM, a biologically active media that Marty Wanalista developed at UCF. And he actually creates a unique blend for each environment because he wants to make sure the transmissivity is right and all that. So he's working with the land to come up with just the right mix. They put, 12 to 18 inches of that in, again, half of this system. They'll have it divided up. So we'll put in lysimeters in both to find out exactly what's transmitting through the control as well as the new. And we'll find out, how successful this is. So it's a biologically active media which has ground up tires, clay, and a few other secret ingredients that Marty has there. And that's what we're working with.